All right, welcome back. Here we go with a whole new chapter, Chapter 5, 5.1, Exponents. All right, so take notes. Have your phone ready in case you need to message me any questions that you might have. All right, so let's first take a look at what exponents mean and what they are used for. So exponents are used to represent repeated multiplication. Okay, so for example, if you want to do this multiplication 2 times 2 times 2 times 2 times 2, instead of writing it like that multiple times, you can just use exponents to represent that. Okay, and here this larger number is what we call the base, and this small number up here is the exponent. Okay, so in general, if you have something that says x to some power n, then that just means x times x times x times x this many times, where this is going to be n factors of x. Okay. All right. Here are some examples. If we have 2 to the third power, that means 2 times 2 times 2. If we have y to the second power, that means y times y. If we have this, negative 3x raised to the fifth power, it's very important here that you recognize what the base is. So here, since we have the grouping symbols, the parentheses, then it's all of this in here. Negative 3x is the base, so the base gets repeated. So negative 3x gets repeated 5 times. Negative 3x, 1, 2, 3, 4, and 5. Okay, because we have grouping symbols here. If I have something written like this, negative 8 to the fourth power, what do you think the base is here? Okay, if you said negative 8, that is incorrect. Okay, so here the base, since the negative 8 is not grouped in parentheses, then here only the number closest to the exponent is the base. Okay, so here only the 8 gets repeated. The negative just kind of hangs out there, and it's 8 times 8 times 8 times 8. Okay, so if you want the negative 8 to be the base, then you would need to put the negative 8 in parentheses, and negative 8 will get repeated 4 times. Okay, so it's very important that you use the grouping symbols around everything that you want to be the base. Okay, all right, so no grouping symbols, then the negative is not part of the base. Okay, so if I have this, what do you think is the base here? Okay, if you said x minus 7, you are correct. So x minus 7 would get repeated again because we see that x minus 7 is grouped inside the parentheses here. Okay, all right, so we're going to take a look at something called the product rule. We're going to be looking at several rules for exponents. So this is the first one, the product rule. Okay, and this here states that if you are multiplying like bases, okay, then when you simplify this, it's going to be the base, and you can add the exponents. again, this is if they are like bases. If they are not like bases, then this rule does not apply. Okay, so for example, um, if I have x to the fifth times x to the third, then according to this product rule, I'm taking the product of like bases, then I can add my exponents, and that would just give me x to the eighth. Okay, let's take a look at why. Why do we add the exponents? Okay, so let's take a look at this same problem, x to the fifth times x to the third. Okay, and if we write out what x to the fifth means, that just means x times x times x times x times x, right? And if we write out what x to the third means, that just means x times x times x, right? Well, this is just repeated, all of this here is just repeated multiplication, and we know we can write repeated multiplication using exponents. And here we see that the x repeats 5 plus 3, 8 times. Okay, and so that's why we have this rule here. Okay. Okay, so let's take a look at a few of these examples here. Let's go ahead and simplify. Suppose I have this one, x to the 11th, x to the 5th, and we'll also do y to the 5th, y to the 4th, y. Okay, all right, so let's start with this first one here. So what do you think the answer is going to be? If you said x to the 16th, you are correct. Okay, and then over here, what do you think the answer is going to be? If you said y to the 9th, you're pretty close. So this y right over here that doesn't have an exponent, it's understood to have an exponent of 1. Okay, so there's this invisible 1 right there. So your answer is not going to be y to the 9th, but actually y to the 10th. Okay, what about these two? Suppose I have a cubed, b squared, a squared, b cubed, and suppose that I have this as well. Okay, so let's do this one first. Okay, so remember, you can use this rule up here, only with bases that match. Okay, so over here, I can use it with the a's. So here I get a to the 5th. And then I can also use it for the b's. And so here I also get b to the 5th. Okay. And here I can use it with the x's. So the negative 8 will just come along. And here, if I use the product rule for the x's, I get x to the 27th. Okay. All right, very good. So that's product rule. If you have like bases, you can add the exponents and we can see why. Okay. All right. So that one is pretty intuitive. Let's take a look at this one, the power rule. Okay, this one says that if you have something raised to a power and then you raise it to a power again, then you can just multiply those powers, those exponents. Okay, so for example, if you have x to the 3rd raised to the 5th, then according to this power rule, that would just be x to the 3 times 5, which is x to the 15th. Okay, so let's take a look at y. Okay, if I have x to the 3rd to the 5th, that means, so if this is raised to the 5th, that means x to the 3rd gets repeated 5 times. Okay, so we have x to the 3rd, x to the 3rd, 3, 4, and 5. Okay, and here, now we can use the product rule because we're taking the product of like bases. And when we do that, we can add the exponents. And if we add the exponents, 3, 6, 9, 12, 15, we get 15. Okay, 5 sets of 3. Okay, so let's take a look. Let's go ahead and simplify these. All right, so if I have this, three squared raised to the third, x to the 11th raised to the fifth, and x squared x cubed raised to the sixth, and let's do x squared raised to the fourth, x cubed squared. Okay. All right, so with these here, so we have this power to a power, so we can multiply the exponents. So this one would give us x to the, not x, 3 to the sixth. Okay, which is 729. Okay, here again we can use the power rule, so we can just multiply the exponents and we get x to the 55. Okay, so here with this one, I'm going to go ahead and simplify inside first. So here, since I have like bases, I'm going to go ahead and add the exponents, and I will get x to the fifth on the inside. Okay, and then now I can use my power rule, and I can multiply the exponents, and I will get 30. Okay, and then this one here, so I'll do this one first. So here I'll multiply, I'll get x8. And then here I will multiply and I will get x to the sixth. And then now I can use my product rule because I'm multiplying like bases. So I will add the exponents and I will get x to the 14th. Okay. Let's go ahead and take a look at these. So here, suppose that I have x squared y raised to the third and 2y to the fourth raised to the fifth. And suppose I have x and y squared to the fourth. And suppose I have negative 6 x cubed over 5 y to the fourth, all raised to the second power. Okay. All right, so going to use our power rule here. So multiply the exponents. I get x to the sixth. And remember, this has an invisible 1, so y to the 1 times 3. And that would be our answer. Okay. Here, I will get y to the 20th power, but don't forget you also have to do 2 to the 5th power. Okay, so 2 to the 5th power and y to the 20th power. Okay, 2 to the 5th power is actually 32. Okay, here we get x to the 4th power, and down below 2 times 4, so that's y to the 8th power. Okay, and then over here, everything gets raised to the second power. So let's start with the negative 6. Negative 6 times negative 6 is 36. And here, multiply the exponents. So that's x to the 6th. 5 squared, 5 to the second power is 25. and then we get y to the 8th. Okay? All right. So that's product rule and power rule. Let's take a look at the zero exponent. Okay, so for any non-zero base x, okay, so x can't be 0. If you take that base, raise it to the 0 power, it will equal 1, okay? And then for negative exponents, okay, so also for any non-zero base x, if you have that base and you raise it to a negative exponent, then you end up taking the reciprocal, okay? And then the exponent becomes positive. Okay? So you take the reciprocal. All right, so for example, if you have 3 to the negative 2, that becomes 1 over 3 squared. Okay, so the exponent now becomes positive. And if you have 2/3 to the negative 2, then you take the reciprocal of 2/3. So the reciprocal, we're going to flip this. So 3 over 2. And the exponent becomes positive. Okay. And suppose that you have this 1 over 5 to the negative 2. So again, you take the reciprocal. Reciprocal here will be 5 over 1, but anything over 1 is itself. So it would just be 5. 5 over 1 is the same as 5. Okay? All right, so let's go ahead and try some. All right. 5 to the 0, so that's just 1. Okay? If I have this to the 0, again, 5x is the base, so this base raised to the 0 is just 1. Okay? But if I have this, again, we don't have grouping symbols around all of this, so only the x is the base. X to the 0 is 1, and we have 5 times 1, which is 5. Okay? Because remember, these are not grouped, so only the number closest to the exponent is the base. If they're grouped, like here, then everything is the base. Okay? And suppose I have this negative 5cd to the 0. So here, only these guys here are the base. This here to the 0 power is 1 times this negative will give me negative 1. Okay? And then if I have this one here, that's supposed to be a 0. Okay? So here, only this one is the base. So this is going to give us 1. So we'll be left with 5b. Okay? Let's take a look at these with the negative. All right, suppose I have 4 to the negative third. Okay, so we take the reciprocal. 1 over 4 to the third. And 4 to the third, do you guys know what that is? 64. Okay. All right. If we have -2 to the -5th power, so this will be 1 over -2 to the 5th. -2 to the 5th is negative times negative times negative times negative times negative. Okay, so that's going to be a negative number. And you could put it in the middle if you want. That's fine. Okay. Whether you put the negative up here, in the middle, or down here, it still means this number is a negative number. Okay. No matter where you put it, it means this number is a negative number. Okay. So it doesn't matter where you place the negative. All right, 7m to the -8. So this m is the base, is not the 7 because we're not in parentheses. So only the m we will take this reciprocal. So that's 7 times 1 over m to the 8, and that's just 7 over m to the 8. Okay, and suppose that I have this -n to the -4th. So again, not all of this is raised to the -4, only the n. So the negative will stay, and the n will move to get a positive exponent. Okay. Again, it doesn't matter if the negative is up here, on the side, or down below, so long as you somehow show that this number is a negative number. Okay. Let's go ahead and put some of these rules and properties together. All right, suppose that I have this, x to the -5th, x to the 3rd. We'll look at that. We'll look at x to the -3rd to the -2. And we'll look at a cubed, a to the -7. And we'll look at a to the -5th power times to the 3rd power. Okay. All right, so let's do this first one here. So here we are taking the product of like bases, so we can add the exponents. So x to the -5 plus 3 will give us x to the -2, but we don't want to end with negative exponents, so we will go ahead and take the reciprocal. Okay. Here I have the power rule, so I can multiply these. So this will give me x to the -3 times -2, which is x to the 6th. It's positive, so we're good. Here, again, we can use the product rule, so I'm going to add the exponents. And that will give me -4. And so I will take the reciprocal. Okay. And then here, power rule. So I'm going to multiply my exponents. And that will give me a to the -15. And I don't want negative exponent, so there we go. 1 over a to the 15th. Okay. So here's just a little bit more on negative exponents. Negative exponents. Okay, so it's still the same idea that if you have a negative exponent, then you take the reciprocal. Okay, so if you have them if you have some up here that have negative exponents and you have some down here that have negative exponents, when you take the reciprocal, then they basically just change places. So the y would move up here and the x would move down here to get that positive exponent. Okay? So it's still the same idea using the reciprocals. Okay, so for example, if I have something like this, a squared, b to the negative 3, c to the negative 4, and d to the 5th power. Okay, so I see that this one has a positive exponent, so this will stay. This one has a negative exponent, so this is going to have to move. This has a negative exponent, so this will have to move. This has a positive exponent, so this will stay. Okay, so a squared will stay. B to the negative 3 will move. C to the negative 4 will move. And D to the 5th will stay. Okay? So that's how you basically take care of them. The ones that have negatives will move. The ones that have positives will stay. Okay? So let's take a look. Okay, if I have these, if I have this will move. Okay, take the reciprocal of that. If I have this one, 2 to the negative 3, 3 to the negative 4, they both have negative exponents, so they will both move. 3 to the 4th will go up. 2 to the 3rd will go down. Okay? If you actually work that out, 3 to the 4th power is 81, and 2 to the 3rd power is 8. Okay. And if I have this, negative 6, p to the negative 2, t to the negative 9. Okay, so the negative 6 is going to stay. The p squared will move, and the t to the 9th will move. Okay, so only the ones that have negative exponents will move. All right, so that's negative exponents. So let's take a look at the quotient rule. So we looked at what we do when we take the product of like bases. Okay, so now we're going to look at what do we do when we take the quotient of like bases, okay, when we're dividing. Okay, so this rule says if you're dividing, then you could subtract the exponents. Okay, so here, this is very specific here. It says m, the top one minus the bottom one. And then if you end up with a negative answer, then just make sure you move it. I kind of break it down to one step instead of two. And I just make sure I subtract from the larger. Okay, so whichever one is larger, you're going to subtract. So here, let's take a look at an example. If you have x to the 7th and x to the 3rd, then according to this rule, we can subtract the exponents, and we would get x to the 4th. Okay, let's take a look at why that is. So if we have x to the 7th over x to the 3rd, x to the 7th means this: 3, 4, 5, 6, 7. And x to the 3rd means this, right? And x over x is 1, x over x is 1, x over x is 1. And we see here that I am left with x to the 4th. Okay, so here you can think of it as canceling. These three cancel with 3 of these up here, leaving you with 4 up here. Okay, so I want you to consider this. If you have it switched the other way, suppose that we have x to the 3rd there and x to the 7th down here. Well, again, it's still the same idea that 3 of these here will cancel with 3 of these here, and you'll have 4 of them left in the denominator. Okay, so You would have 1 there, but you would have 4 left here. Okay? So you can think of it more as canceling. Okay? Let's take a look at a few examples. All right. So if I have a to the 5th over a to the 3rd, so 3 of these will cancel with 3 up on top, leaving you with 2 on top. Okay? If I have this, 2x to the negative 5th power, x to the 11th power. Okay, so here you could do the quotient rule and subtract them, or you could use your negative property and move this down to the bottom and then do your product. Either way is fine. Okay, so I like to move them. Okay, and then now I can use the product rule and add the exponents. There's no particular way to do it. If you want to do the quotient rule, you can. Okay. If I have this one, x to the 4th, x cubed, x to the negative 5. Okay. I like to move my negative exponents around. So I'm going to go ahead and bring the x to the negative 5. I'm going to bring that up. And then I'm going to use my product rule, which says to add the exponents. And I get 12. Okay. If you have this, okay, so using my power rule, I get x to the 6 up here, and down below I get x to the 6 as well. And here I get 1. Anything over itself is 1. Okay, let's take a look at this one. 7x, y to the 4th. Okay, so here, this one cancels with 1 up here, so I'll have x to the 1st up. The 7 will stay. Nothing happening with the 7. And then over here, these 3 will cancel with 3 here, leaving me with 1 down below. So that would be my answer. Okay. All right. Let's take a look at a more complicated one. Suppose that I have, let's put all the exponent rules together. So if I have that, and I have this. Okay. So oftentimes students aren't quite sure how to begin. Again, there isn't any particular order on how to use the properties. So long as you use them, you'll be fine. You know you're done with simplifying this problem when you have only one of each variable. Like here we have 2 A's, here we have 2 B's, so we know we're not done. And you don't have this power hanging around outside. It gets used. And you don't have any negative exponents. Okay, so clearly this is not simplified. Okay, so you could work inside first and then multiply by the exponent out here. Either way is fine. Okay, I'm going to go ahead and start with this exponent out here. So all the exponents, remember these have ones, will get multiplied. So this is going to get 2 to the 3rd, a to the negative 6, b to the 9th. This down below, 3 to the 3rd, a to the 15th, and b to the 12th. Okay, and then I like to take care of my negative exponents. I like to move them. Okay, 2 to the 3rd is 8, so I'll take care of that as well. And 3 to the 3rd is 27. Okay, So B9 will stay, but A6 will move down. A15 will stay, and B12 will stay. Okay, so the only thing I did here was multiply this out, and I moved my negative exponent. All right, so now I'm going to use my rules. So here, product rule. So I'm going to add the exponents, 6 and 15. 6 and 15, that's 21. And then here, B9 and B12, it's quotient, okay? So these 9 will cancel with 9 of these, so I'm left with B3 on the bottom. Okay? And that would be your final answer. We see here we don't have any negative exponents. We only have one A and one B. Okay? Okay, let's take a look at a few more. That was F. Let's take a look at one. Let's do one more example. Why don't you try this one and then see if you get it. So A negative 2, B3, A squared, B3, no, A squared, A cubed, B4, and everything raised to the negative 3. Okay, so go ahead and hit the pause button and come right back to see if you got the same answer. Okay, so I'm going to take care of all the exponents with this. So multiply all the exponents by negative 3. So there, I'll get A6. Here, I'll get B negative 9. Down here, I get negative 6. And here, I get negative 9. And here, negative 12. Okay? All right, I'm going to move around my negatives. A6 stays. B9 will move down. Okay? And then A negative 6 will move up. A negative 9 will move up. And B negative 12 will move up. Okay? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're all accounted for. So now my A's, that's all products, so I can add the exponents. Okay, so 12 plus 9 is 21. A to the 21 power. And here, quotient rule, so I cancel. These 9 cancel with 9 of these, leaving me with 3 up above. Okay, so this would be the final answer. Okay, all right, if you have any questions, make sure you email me, make sure you text me. I will see you next time.